Hey guys, happy Monday. Today we are doing the 7.3 extension on the triangle sum theorem, which is basically just talking about the angles in a triangle and what they add up to. So in order to show you this before we jump into the book, I wanted to show you a visual. If we have a triangle and we have an exact copy of the same triangle, and we take it and turn it around and piece it together, it creates, if these were exactly perfect, a rectangle. And again, I know that that's not perfect, but you get the idea that a rectangle or square is made up of two triangles. So with that in mind, we know that a rectangle and a square has four 90-degree angles. So if we cut it in half, well actually let's go back for a second. 90 times 4, if we're talking about the sum of the angles in a quadrilateral, would be 360. So if you're cutting that in half, you're dividing 36 by 2. That would be 180. Okay, so the sum of the angles in a triangle is 180. This is one of the ways that you can prove it. Now let's get into the actual lesson. Okay, so this part is going to seem a little funny, but basically all they're saying here is that if you have three angles, call them X, Y, and Z, when you add them up, they're always going to equal 180. I encourage you, even when they seem really obvious, to set up an equation every time so that when you get to the harder ones by the end of this lesson, you will know what to do. Okay, so here we go on our first examples. We know that this triangle has a 28-degree angle and a 50-degree angle, and we're trying to figure out what X is. You may be tempted to just say, okay, what's 180 minus 28 minus 50? Don't do it that way. Set up an equation. We have X angle, we have 50 degrees, and we have 28 degrees, and we know that that equals 180. So we're going to simplify by adding those together. It's going to give us 78, and then we're simply going to subtract. So that's going to give us 152. Oops, that was a 7, not a 2. My mistake. That should be 102. So the missing angle is 102 degrees, and you can always check that by adding it back in. So just like you used to do when we were solving equations, you're plugging your answer in for X to check. So yes, you should always check. So 102 plus 50 plus 28 should equal 180. We already know what 50 plus 28 is, and that's 78. So when we add 102 plus 78, do we get 180? And the answer is yes. 102 plus 78 does equal 180. So we've checked it, and it's good. Okay, we'll do this one in purple. Second one, you may be wondering why they only gave you one angle measure, but they actually gave you two. They just didn't list out the numbers. So once again, we're going to set up an equation. X plus 45 plus 90 equals 180. Combine and solve for X. And that's going to give us 45. So the missing angle measure should be 45, and then we'll check. So we're saying, does 45 plus 45 plus 90 equal 180? And we know that 45 and 45 is 90, and 90 plus 90, I'm running out of space down here, does equal 180. Sorry about this, guys. I can't get my extra lines in there, but you know what that's supposed to say. Check. That works. Now, another thing I want to mention about this one, because you may have noticed the markings on there, and we talked about this in the last video when we were talking about triangle classifications. This is an isosceles triangle. And in an isosceles triangle, the side that's across from the angle measures that are equal, so this being 45, are also equal. So you may have been able to tell that this missing angle was 45 just on the fact that they told you that these two side lengths were equal. Okay, you know that that one's not going to be 90. That wouldn't be possible. If you had 90 and 90 in the same triangle, that would already be 180. So it wouldn't be a triangle. Okay, moving on. These ones are just a little bit more complicated before we get into the toughest types. So our real life example problems are, we've got these flags. In this one you're missing two. I'm actually only going to do one of these because they're basically the same thing. So if we have x plus 128 equals 180, in this one we have two x's. So combine those two x's, and that actually tells us, again looking at the markings, that whatever we get for x is going to be the same for the other one. And that's because this is an isosceles triangle. So we're going to solve. This one's going to be one more step since we have to get the 2 away from the x. That's going to give us 52. And then we're going to divide it by 2. And that gives us 26. And we're going to check it real quick. When we plug in 26 and 26 again, because those were our x's, plus 128, that should equal 180. So 26 and 26 is 52. Add that to 180, or to 126, and we should get 180, 128, my bad. And yep, 180 does equal 180. So that is correct. So that means up here, going back to the picture, both x's are 26 degrees. And we knew that again from the markings, that two of the angles were going to be the same. Just to quickly look at letter B, even though we're not going to solve it, I don't know if you noticed that this is 60, and it looks like an equilateral. And in fact, when you divide 180 by 3, you do get 60. So each of these would be 60 degrees, because that's an equilateral. So another word to the wise, if they give you a triangle and it has 3 equal sides, it also has 3 equal angles. So whatever they gave you is your answer for the other two. Okay, we're going to look at 2 more types of problems really quickly before you go and practice this. Notice we are not doing any on your own, so it's going to be a little bit different today. Okay, so I'll just do one of these, because you will see this come up. Tell whether a triangle can have the given angle measures. So basically they're saying, could you have these 3 angle measures in a triangle, and would that be an actual triangle? Because if it's not 180, it's not a correct triangle. So we'll just do the first one, number 7. Don't worry about these ones. To test this, all we have to do is add them up. Don't forget, when you're doing this, you want to line up the place value. So if we were doing this one, the 93 would be 93 and 0 tenths. The other two have the other tenth places. Okay, so 7, 8, 9, 10, carry the 1, 6, 7, 8, 9, 10, carry the 1, and that is 15, 16, 17, 18. So yes, that one is a triangle. And actually, I changed my mind. I am going to do another one here, just because I want to see what happens when we don't have a triangle. What would we have to do to fix it? So let's go ahead and try this one. We have 93, we have 115 and 1/10, and we have 47 and 5/10. We can already tell that this isn't going to be perfect, looking at the place values, because that's a 6. Alright, so 7, 8, 9, 10, That's 15, carry the 1, 9, 10, 11, plus 4, 255 and 6/10. That's not going to work. That's way more than 180. You actually probably could have told that just by looking right away. Remember we talked about in the last video that if one angle is 93, the other two would have to be acute. And the reason for that again is if you have a right triangle and one angle measure is 90, there's only 90 left because 180 total minus 90 only leaves you with 90, which would mean that these two have to add up to equal 90. I don't know why I just wrote 29, but that should have said to equal 90. So that could be any combination that would equal 90, but not something more than 90. So there was no doubt about the fact that that could not work. So then what they want us to do is to make it work, okay? So change the first angle measure so that the angle measures form a triangle. All right, so the first angle measure was 115 and 1/10. We're just gonna get rid of that one, and we're gonna say x plus 47.5 plus 93 equals 180, and we're going to figure out what that missing angle would have to be. Okay, so we're adding these two together. I'm just going to stack that up top. 47.5 and 93. 9, that's 13, 140 and 5/10. And again, I know you're going to be tempted to just subtract and move on, but you don't want to do that. We'll see why in just a moment. Okay, fill in that place value. So we're going to be doing some borrowing here. And that's going to give us 39.5. So then we would just check it. Does, when we plug it back in, 140.5 plus 39.5 equal 180? Yes, it does. Okay, so it would have to be 39.5. That first angle measure would have to be 39.5. All right, here's the last type. And I know you're thinking, oh, what is going on here? You don't have any of the angle measures here. All you have are algebraic expressions. So, this is exactly why you wanted to set up your equations, just so you are in good habits. Please do not overthink this. Every single time you do the exact same thing. You take your three angle measures, you add them up. So this angle measure right here is x. You're adding it to another angle measure, that one we know is 90, and you're adding that to your third angle measure. Just leave it the way it is, set it equal to 180, and then we have to solve. So it looks crazy complicated, but really we're going to combine like terms and it's going to be a simple equation. So we have 1x and 2x, that gives us 3x, and then we have 90 and 15, and that's going to give us 90 and 15 is going to give us 105. And that equals 180. So then just solve for x. Three x is 75. Divide by 3 to see what x equals. And I get 25. So that is what x equals. I know how I feel about this. We talked about this briefly. I don't agree with your book that that's where you should stop because all you have found was x. If they ask you to find x, then great, you're done. But if they ask you to find the angle measures, you're not done. You have found this one because this one is x. So that's 25 degrees. This one's already done. That's 90 degrees, but you would still have to figure out what this one is. So you would be doing 2 times 25 plus 15. So 50 plus 15, which equals 65. And then last but not least, I would always double check to make sure that that equals 180. So basically, since this one's already 90, you just have to make sure that these two add up to 90. 65 and 25. 6, 7, 8, 9. Yep, it does. So 90 plus 90 equals 180. And that's done. Alright, so I am not going to do that last one there for the sake of time. Now that you have seen this, you're going to go and practice. Thanks, guys.